In this video, we will be going over the theory behind the math examples. Let's begin now on MathCat. 3, 2, 1. There are some numbers whose square root cannot be written as a single digit. Two numbers multiplied together that equal 3. That's what the square root of 3 is asking us. Well, you'd think that would be easy, but if you plugged it into a calculator, you're going to get a string of digits that looks like this, depending on how many digits your calculator has. And I'll just put 3 dots because this number actually goes on forever. It's a long string of numbers. And if you multiply this long string of numbers together, however many are showing on your calculator, in my case, I multiplied this times itself. I didn't even get 3. I got something like this with a long string of 9s. And now finally out here I had a 7 and a 4. Well, that's not 3. It's very close to 3, but it's not 3. In fact, you would take an infinite number of digits multiplied together to get 3. Well, what do? The square root of 3 is written this way. In fact, if you multiplied this number times this number, you'd get this number. If you multiplied negative this number times negative this number, you'd still get the positive version. So we write the square root of 3 as plus or minus the square root of 3, with the radical sign still showing. Or really, we don't even have to write the equation. We just represent the square root of 3 like this, and in most equations like this. We don't even show the plus or minus. But this, of course, has a negative value as well, outside of the radical. Turns out the square root of 2 is a number similar to the square root of 3. It goes on forever. ... And it's a long string of numbers. And it's also a negative long string of numbers. Both multiplied by themselves will give something close to 2, but of course you need an infinite number of digits to really get back to 2. So we write the square root of 2 either like this or like this, but there is no way to accurately show what square root of 2 equals.